Hi everyone, my name is Ite Greenberg and I'm the Chief Strategy Officer in Check Point. Today we're going to talk about how to use AI and machine learning and automations to actually prevent cyber attacks. So let's start. So I'm starting my day looking at this map. This map is showing me the last year and a half, 2 years of attacks that we've seen out there in the wild. We have a big department here that are doing research, like hundreds of people that's what they do research of cyber attacks. And we see that obviously APT and supply chain and ransomware and software vulnerabilities are the most common type of attacks that today are used in order to get into your assets, into your network, right? I want to focus about the supply chain attacks. This is something that is quite new, but we are all facing it quite severely over the last 2 years, starting with SolarWinds when it started around 2020, and we all wake up with a massive attack that actually took over and over about 18,000 customers. And then we had Code Cove that infected 20,000 employees. And then Log4j that started as just a vulnerability, and then it becomes a Log4Shell where the hackers started to attack the companies. And what we see is that with a single attacks, in a very short time, we can impact so many customers. And it's very clear that we cannot only rely on technology that come up with signatures, that post the attacks. After the attacks is known, we are fighting to remediate. We need to come up with a preemptive technology that prevents the attacks before it happens. And that's what we believe in Check Point we need to do. AI is one of the important tools that will allow us to do so. By the way, we in Check Point, we noticed about 800,000 attempts of Log4j during the first year after it started. So as we can see that it's here all across. On the flip side, if you look at what happened when the attacker actually takes over and attacks my company, is one of the things that we'll try to do is to apply a ransomware type of attacks. What we see here is that it used to be kind of, I asked a few $100s for a ransom, and now we see even ransom attacks that are asking for $40 million, and customers are willing to pay millions of dollars to get the data back. But the hackers became even more sophisticated because they're not only going and asking the victim, customers they apply the attacks against, to pay the money. They will go also the consumers of the victims. For example, what we call double or triple extortions of the attacks, and they will try to utilize and ask for money from multiple victims of the same attacks from the same customers. So we look and we see that there are so many types of attacks, and attacks are becoming more sophisticated as we see. Yet customers are dealing with a problem where they have a SOC, they're investing a lot in SOC, that have too many alerts, which they don't know what to do with the alerts, because once the attack is in their network, once they have machines compromising their networks, it's a lost game. You are chasing now the computers that are compromised. They have too many point products that are not communicating with each other, and yet another very important problem they're facing. And even if they have the technology with some vendors, and the technology is available in the market to most of the cases to fight against those attacks, they are too slow to implement and to deploy them in their environments. So what we believe, our philosophy in Check Point to deal with this kind of challenge is, first of all, think about preventing the attack. Not only detecting, generating alerts, asking for the SOC people to go and remediate, but really prevent the attack. Now, I'm not saying that you don't need to spend some dollars on SOC and you need to look at resiliency, but if you have a bucket, if you have a budget of your security in your environment, ask yourself, how do you divide it between technology that really prevents the attack, technology that you put inside your SOC and people that you spend on your SOC, and technology that will give you resiliency. As I mentioned again, we in Check Point strongly believe in this bucket of prevention. And that's what I'm going to talk to you about today. How you can really prevent the attack. Now, prevention is a tricky thing to do. It's quite challenging because, one, when you do prevention, you need to do it very fast, even before we know about the vulnerability. We need to have a technology that really prevents it in a very accurate way. that doesn't generate false positive. And we need to be able to do it without slowing down the users. For example, if I'm downloading a file from the internet, I don't want to wait 2 minutes for some emulations technology to do the emulations for me, or when I'm sending an email to someone. Again, I don't want to wait. So everything needs to work very, very fast and needs to be very, very accurate, and before the hackers know how to leverage the vulnerability. It's not easy. Another way to deal with prevention, and before even you do the preventing the attacks, you want to reduce your attack vectors. And that's the whole idea of zero trust. So I want to narrow down, to harden my environment to the level that a user can access only the application they're allowed to access and nothing else. Or for example, a workload can communicate with another workload, with another application, but nothing else. So I need to come up with a zero trust policy that says only the communication that is allowed, there is a policy that enforces it. And again, this is a very complex task to do, because if you think about it, today, if I take, for example, Checkpoint products that are deployed by some of the largest data centers in the world, by some of the largest financials, you would see a policy of Checkpoint with hundreds of thousands of rules. So if you have like 20, 30, 40,000 rules, to manage them, this is already a complex task for humans to do. If you really want to deploy a full zero trust approach, you will end up with hundreds of thousands of rules that allows communication from every workload to every workload. To do it with a human intervention, with tickets that you create a rule, it's not achievable. So you need a machine learning, you need a different approach how to do it with guardrails and identity-based policy and automations that can scale up for a large environment in order to achieve a full zero trust approach. Now, we in Checkpoint, we are focusing on 3 areas that I'm going to talk about and give you some examples for AI and automations that we are implementing. One will be around the network. We call it Quantum, how we secure the network. Second is CloudGuard, is how do we secure the cloud. And third will be Harmony, how do we secure remote users and access. Just between you and me, I want you to know that we in Checkpoint today, we invest half of the R&D in cloud and Harmony, and only the other half is what we know to be the leaders in the industry in Quantum, just for you to know. Anyway, let's continue. So my story will be that we need to protect all 3 areas, the network, the cloud, and the access with AI technology. But to do a good AI technology, you need to have a platform. You need to have something that sees the world, and that's what is Threat Cloud. You see the line under that says Threat Cloud? That's what I'm going to start with. So Threat Cloud it's something that runs in the cloud. For us, it's running in AWS, Azure, our own cloud, doesn't matter. But all the Checkpoint products, by all the Checkpoint customers, will consult with the Threat Cloud. And they will consult with him about malicious URLs. For example, you can see here that on a typical day, we see about 2 billion websites. So we inspect, we know about 2 billion websites. This is a daily. Or we inspect every day about 13 million files. We see about 900,000 malicious mobile applications on your iPhone or on your Android. So we actually see the world, and we know about all these type of indicators that might be malicious, that will try to attack your network by seeing the world, by seeing in different environments. But the thing is that Threat Cloud have 2 sides of the brain. The indicators, it's kind of a static information. It's all the things that we already know, and that's the right side of the brain. The left side of the brain are a long list of machine learnings and AIs that we developed in order to make decisions that are in the gray area, things that are not clear, that are not, we do not have an indicator, an IOC that tells you if it's good or bad. And today I'm going to go through some of those machine learning algorithms that we have in order to explain to you how do we do it, how do we help you to make, or how do we help our products to make a decision. So as I showed you before, or as I told you before, we have the right side of the brain and the left side of the brain, and this is the Threat Cloud, and all the Checkpoint products from Harmony, from CloudGuard, from Quantum, they're all communicating with Threat Cloud from all customers. You can also see on the left side, we have the Threat Cloud APIs, meaning that you can consume if you want the intelligence from threat clouds. We are giving you APIs for the different indicators to consume. I talked about threat cloud, and I'm going to talk about how do we use the AI. And remember, I'm going to talk about the different 30 type of AI engines, and I'm going to show some of them. So let's start with going into example in the quantum space, in the network space, okay? The first one that I want to talk about is what do we do with files, okay? So let's say that on the left side you see the executables. I'm a user, I'm downloading these executables from the internet. Or maybe someone is sending me an email with this attachment of the executables. So we have Quantum, that Quantum is the Checkpoint appliances. We take this file and we send it to Threat Cloud. And Threat Cloud is doing multiple things. First of all, it will check against multiple different AI engines. You can see deep learning, file reputation, machine learning. We run different type of, that I will show you a later after some of them, but we are running through multiple engines together. And then we sending it into a verdict that takes the scores from all of them and make a decision. So by doing so, we can get to a very, very fast and accurate decision with files that you download from the internet or when I'm sending it to you over email. So Malware DNA is a good example of one of our machine learnings that we do in order to help understanding the nature of the file or of the malware. Yes, every malware have its own DNA. Actually, inside the code, the attacker will plant some hints about the malware itself. And you will use this malware against a known vulnerability in different ways. The way we actually know how to correlate this malware into a family of malwares, we're doing some classification. We use a code analysis, behavior analysis, binaries analysis in order to eventually tell you, you know, this file is a malware and it belongs to a family of malwares that we've seen in other events, in other customers, and maybe it's not the same, but it's part of a family. And that's a good technology that we use in order to help us making a very fast verdict. Another good example of machine learning and technology that we use in order to analyze the malware is around DNS. And with DNS, we do more than one thing. The first thing that we do is domain generation algorithm. If I'm the hacker, I will take over your computer and would like to take this infected computer to communicate with a command and control outside your company in the internet. Now, the problem will be is that someone will try, the hacker or the infected machine will try to come up with a different type of command and control, so you don't know how to block it in the middle. So this is how I will generate a domain in order for you to bypass your technology that will prevent this communication with the bot. However, what we do in Checkpoint, we kind of learning the way the hacker generating the domain. We're using different techniques. We see if the domain is new or not. We see how actually it's generating the new domain, and we can predict the next domain that is going to generate and to communicate with. And by doing so, we will prevent the infected machines to communicate with the command and control. Another technique that the hacker will use with DNS is to leverage the DNS protocol itself as a means of protocols to transport data, as a tunnel to transport data outside the company. Instead of sending it via the email or via HTTP, I will use the DNS because it's an open protocol that is open to the internet. Quite easy, right? So again, we will look inside the DNS, not only that we will enforce the DNS RFC, but we will also look that you are not trying to take over the DNS in order to transmit data outside. So we use different type of algorithm. We use neural networks in order to deal with these two type of DGA and DNS tunneling protections to eventually come up with a decision that prevents this attack. So this is what we do around DNS, and we have a lot of other things that we do in DNS, but I gave you two good examples. At the end of the day, what the technology that I showed you with machine learning and AI helps us to provide better security than others to protect you against unknown attacks. You can see here three good examples with Tickbot and Zloader and other that we eventually provide a mitigation security solutions days and sometimes weeks before they are even known on VirusTotal. just an example. Another good technology, a way that we use in order to help you with preventing attacks is with the MITRE framework. And the MITRE framework, actually we use it in two ways. One is to give you some indication, knowledge about how these attacks, malwares, match the MITRE framework. Great, so we educate you. But we also take the framework in order to enhance our prevention algorithm by correlating the attacks into other attacks that match the MITRE framework. So we use it in two ways. We talk a lot about prevention, but I want to go back into the zero trust policy. And even here, I mentioned before that we really need to go into automation and something that helps me to automatically adapt my policy into the environment. If every change that I'm doing in my environment, if I need to allow users to access application, a database administrator to access the databases, machines to access machine, everything I need to open a ticket, I will slow down my company. I will not be able to provide the policies that I need, and I will create policy that is too permissive, which is not good. So what we did, we actually came up with a solution that actually learned about the environment. We do it by integrating with APIs to all the different types of identity providers. Your IDP, your user identity, whether it's Okta, Ping, or Azure AD. We're integrating into application identity, whether it's SAP, Jira, ServiceNow, and into also network identity, whether it's Cisco ACI, VMware NS6, AWS, Azure, Google, Oracle. We bring via APIs all the identity into Checkpoint, and instead of defining policy based on IP to IP, we define a policy based on identity to identity. So if, for example, I create a rule that says from database administrator, which is an object that I brought from Okta, to database security groups that I brought from AWS or from NS6 or from others, every time that something changes in those identities, via API, I get to learn about it, and automatically I update the enforcement point, which can be in your network or in the cloud or on your endpoint, doesn't matter. So this is how you automate your policy in order to get a more accurate security, zero trust policy, and reducing dramatically your operation cost. I talked about different types that related to zero trust. This is also very important to zero trust, which is the ability to automatically identify the identity of the IoT, of the assets that you want to secure. And we're using different technology to automatically classify, identify the IoT. It's a printer, it's a security camera, it's an elevator, whatever it is. But we don't stop here, because those IoT devices, OT devices, they communicate with the command and control, whether it's in your data center or whether it's in the internet. So it's important also to automatically define the access policy, the zero trust policy for those identified assets. And we go all the way to what we call autonomous firewall that automatically, and you see the word automatically AI, it's repeats itself all the time in my presentation, to automatically define the policy that allows this access, the zero trust access for your IoT and OT. So we talked about how we do it in the network, but I want to show you also how do we do it in the cloud. So network was a big part. We talked about the left side. Now let's talk about the middle box, the cloud. Now the cloud is a journey. When you move into the cloud, you have a journey to secure your cloud. It starts by, first of all, as we see the journey, to secure your DevOps, your code, whether you use open source, whether you use different type of application before they're even in production. In this space, we just, by the way, acquired a company, Spectral, that allows us to secure the code, looking inside your known vulnerabilities in open source, looking for tickets or passwords that you left inside your code, actually helping to harden your code in the shift left space. Second is, how do you secure your network in the cloud? Even in the cloud, you have network, application communicating with each other, users are communicating with application. It all goes through some network platform, and we integrate to all the cloud network platform, whether it's in the public or in the private. So we have the cloud guard network. Then you want to have posture. Again, posture, they have two sides. You have the posture during CI/CD phase, making sure that even before you are in production, your environment is fully hardened and you don't do stupid mistakes. And when you're in production environments, you want to constantly scan your environments to make sure that it's fully hardened, that the developer or via some automation or manual things, someone didn't put your solution, your cloud environment at risk. So this is the posture management, again, a company that we acquired several years ago. Then we have AppSec. AppSec is you have the users or maybe a mobile application communicating with a web service. Again, via API, RESTful API, whatever API you choose for. Today, it's imperative, it's important to put a security in between your application and the consumer, the users that are accessing this application. And it's very important to look at the API calls. Then you go even deeper into the workload itself. Can be container, serverless, virtual machine, doesn't matter. Inside, you want to make sure that no one is trying to manipulate with the system call, with the memory, with how you actually interacting with the application in runtime. But not only, by the way, also in shift left. And the last point is across everything that I showed here and everything that the native clouds provides, logs, alerts, whatever data that we collect, we provide you an intelligence across everything. So I showed you what does it mean to secure the cloud and the journey to secure the cloud. The thing is that many vendors that you will look out there will give you maybe a point product. We give you a full solution, but they will only give you a solution that gives the detections, which, by the way, we do as well. It always starts with a detection. So we do CloudGuard posture and intelligence to do some detection. But the difference between what we do and others is that we do not stop here. We go to auto remediation. We have technology which we call CloudBots and CloudGuard shift left and things, and the Spectra, the technology that we acquired that automatically remediate the mistake that you do or the problem or the vulnerability that you have inside your cloud environment. And even more, we actually do the prevention. We do it in the network, we do it in the API, we are doing it in the workload. And that's, again, don't assume that you can do everything in the shift left. You must do things in the shift right. You must do things in the production to stay secure. Let me explain, for example, what we do in the case of posture. So today, you are bombarded with a lot of vulnerabilities in the open source and things that you have open in your environment in the cloud. And then you ask yourself, okay, I have so many alerts, so many problems. What should I do first? I don't know how to deal with everything. That's a wrong approach. Using machine learning and AI, we're actually collecting all this data and we're learning and we are coming with an effective risk factor that tells you, you don't need to deal with all those type of alerts, security alerts that you have. Deal with only those top 5 ones that we find for you. And we tell you that if you solve those ones, this is like the 80-20 rules. Solve these 20% of the issues, you increase your security dramatically and your health of your environments dramatically. But then, as I mentioned, we are moving into the workload itself, into the API, into the serverless, into the containers. And we have a lot of technologies there, which today I don't have time to zoom in and to explain. We wrote some of them. But again, I promise that I told you that we do things that others don't. This is a good example. Think about Log4j. We actually prevented Log4j before anyone knew about Log4j, before there was no Log4Shell attack outside there. Why? Because we did it via machine learning and AI, we did it in a preemptive way. Everyone else, you're required to install or to get some signatures to deal with the Log4Shell. But the problem is that every day I had a different variant of Log4Shell, so for every variant of Log4Shell, I had to have yet a new type of signature. Okay, that's an old way of dealing with zero-day attacks, or actually doesn't deal with zero-day at all. How do we actually do this kind of magic? Again, let me explain you in high level. We're starting by doing kind of initial analysis. We take all the traffic that goes through via APIs. It's a solution that is installed between your users or your mobile application and your backend API service. And you can install it, for example, on your Nginx as a reverse proxy. Now we see all the API calls. And we are doing some initial analysis by looking at the base64 coding, initial payload analysis and things like that. And then we are passing only around 3 to 5% of the traffic into AI-based scoring mechanism, which we then look at what the user is doing with different type of APIs. How many users dealt with a very specific API calls? What happens with those kind of calls outside the scope of this specific customer? So we use different type of scoring mechanism. We take everything together. We are running, again, an AI that calculates the scoring and provides a verdict, which is a very, very accurate verdict. And today, this solution is deployed by customers in a real production environment that actually protect them from Log4j. So I talked about how we do security in the network, in the cloud. Let's talk a little bit about how we do it also for the users. When you are working today from home, you're opening your laptop and you are doing whatever you want to do from home, right? So here, I would like to talk about phishing. Phishing is the most easiest and convenient way for hacker to start the journey of his attack. He will send you maybe an email to your corporate email. Or you know what? He will send you an email to your private Gmail. Or maybe he will just send you a phishing link to your SMS or to your WhatsApp or to your whatever social media that you use, right? So you can think that you have a technology that protects you from your corporate emails from getting a phishing links, right? But do you really have this kind of technology deployed in all the other type of attack vectors? So what we did in Check Point, we said, okay, the same phishing link the hacker can send in multiple attack vectors, we will protect against all of them, number one. But then we have a lot of different type of algorithm and machine learning, again, to look into the link itself, into the images within the web page, into the domain and how the domain looks, and into the, if it's an email, we look at additional indicators about the sender and the body of the email and the title of the email and many other different algorithms. As you can see here, 300 indicators that we look to predict and to make a decision whether it's a phishing link or not. Or spear phishing or type of advanced phishing technology that hackers are using today. To summarize, guys, I think that I told you that I'm starting my day looking at the different type of attacks that happened over the last year and a half. I'm finishing my day by looking at this kind of map that, again, MITRE is giving us, that explain the chain, the evolution, the cycle of attacks. From the entry points to the gaining persistence, to the lateral movement, to the data leakage. And my role and what we do in Check Point is trying to think how we can prevent this attack on each one of those individual stages. And that's how we actually can gain to or get to the point where we can actually prevent the attack. We're doing it across the entire environment. We're doing it across your cloud, your network, your IoT, your mobile device. And we're doing it with a very strong threat cloud, which gives us all the intelligence and the AI that runs there. If you want to learn more about what we do in Check Point, you're welcome to read some of those materials and obviously visit our website. And that's it for today. Thank you very much, and I hope you enjoyed the session.